And then some of you will go to grad school and they'll be like, okay, now do a lot of math. And you're going to be like, oh no, I should have listened to Professor Verbeek. Okay, if I give you a collection of numbers, what is the average of these numbers? What is the average of this collection?
Added divided by n.
Huh?
Add them all together and then divide by n, which is
Sigma 1 to n x over n.
I'm going to do this instead. Sigma, little x and big X. You're allowed to do this. Yeah. Like this is a bigger.
Oh, okay.
Yeah. That's why in my. That's
Okay.
the yeah. I'm going to add them all together, and then divide by the number of symbols. Everyone can relate to this, right? This shouldn't be news to you that this is how you calculate the average of some numbers. Let me rearrange this a bit. I could rewrite this as sum x in big X of x times 1 over n. What does that look like?
Oh,
That looks like a
the thing.
Riemann sum. This looks very close to a Riemann sum, doesn't it? Okay, so I'm just going to point you to something. Check this out. Notice, let's just look at this value. 1 over b minus a of the integral from a to b, of f of x dx. And I'm just going to give the left endpoint estimation of this, which is going to be 1 over b minus a, limit n goes to infinity of the sum k equals 1 to n. And let's just count from the left like this. And then delta x is going to be b minus a divided into n pieces. Follow? It's just the normal Riemann sum. Okay, but let's fix n.
Shouldn't it be k minus 1?
Pardon me?
Isn't it a plus k minus 1 times delta x? Because it's left hand, and then the right hand is just a plus k times.
Oh, you're right. You're right. That's a right endpoint estimation. Thank you. Yeah, thank you. Okay, let's now just remove this limit. Just fix n. Just choose something big, right? So fix n. And we have what? That this is equal to 1 over b minus a, sum k equals 1 to n of fa plus k delta x, b minus a over n. But what happens with this and this? They cancel, okay? So what are we left with? We're left with, this is the sum from k equals 1 to n of a plus k delta x, 1 over n, which is what?
Which is the average
Of what?
of a bunch of numbers being added together.
Yeah, but we know them specifically. It's the average of these. It's the average of these quantities, specifically. Right, so if I give you a function, and we go from a to b, and we just like choose a bunch of points, okay? This sum is giving you the average height of these points. That's one way to interpret it. Now, what happens if I put the limit back in? What happens? So I'm telling you, like, with n many samples, you're going to get the average height of n many of these points. If I push that n to infinity, what are we getting the average of?
The entire curve.
The entire curve. Right, so in order to say what is the average of f of x such that x is in the real interval a to b, so remember how this is a problem? We can't even count through this. There's like an infinite, like there's a uncountably infinitely many things in here, right? This is basically just the whole curve. This is going to be equal to 1 over b minus a integral from a to b f of x dx. Right, because everyone with a finite n is giving us the average of n things, and in the limit is going to give us the average of the infinitely many things. The end. This is how you take the average of a curve over an interval. Because really that's all that's to it. You just integrate over the interval and divide by the interval. Any questions on that? We'll do a couple examples, but they're easy. Right, this is very simple, right? I can pull out the average. Okay. Okay, so let's ask some questions. What is the average height of cos over 0 to 2 pi? Okay, first intuitively tell me what the answer should be. If we look at a whole period of cos, what would we expect the average height to be? Yeah. 0. I think you're right. So the average of cos theta for theta in 0 to 2 pi is going to be equal to 1 over 2 pi minus 0 integral 0 to 2 pi cos theta d theta. It's going to be equal to 1 over 2 pi sine theta from 0 to 2 pi. Both of those evaluation points are 0, so this ends up being 0, as you predicted. All right, let's do something harder now. Let's do the same question, but over a different domain. Pi half. Okay, so what happens if we do this again? Cos theta over 0 to pi half. Again, that's easy. It's just the average value of cos theta such that theta is in this interval now, which is going to be equal to 1 over pi half minus 0, integral 0 to pi half, cos theta d theta, which is equal to, you can see that this goes to 2 over pi, sine theta 0 to pi half, which ends up evaluating to 2 over pi. That's really all I have to tell you about averages, right? So as long as you remember this simple equation and remember sort of some of the reasoning, questions like this should be easy. So I actually wrote down like a real sarcastic exercise in the notes, then like, I can't write this, and I threw it away. But the exercise was like, pick your favorite function, pick your favorite interval, find the average, right? Like it just, you pick, it doesn't matter. I'm confident that you guys can definitely integrate. So this is just basically one, now you can answer an arbitrary amount of questions on averages, which require you to do integration. So there are some lingering Weeby work questions which ask you averages. So now you can go and you can do them now. Any questions on this? Okay, good. So that was lecture 1. So we're going to do lecture 2 now. Maybe I'll break up the video into 2 pieces.
And designate the second one as a bonus.